There are several ways to solve this question. The fastest way is to recognize that an isosceles right triangle is actually a 45-45-90 right triangle. And this triangle has a special ratio that we can use for its lengths. So isosceles right triangles, again, are 45-45, not 44, 45-45, 90 triangles. And this implies the ratio of sides, which would be the leg to leg to hypotenuse, which is equal to x to x square root of 2, or 1 square root of 2. This is just the ratio scaled by some multiplier x, so either or will be fine. We don't know the sides of the triangle, so we would call just the leg x. So the ratio still holds, it's just scaled by whatever size the triangle is, and we're just calling that x for now. Now, since we're given that the hypotenuse values for the answer choices, because that's what we're asked to find, it might be easier to deal with the hypotenuse if we called the hypotenuse x. So in order to do so, we can actually multiply and divide this ratio, kind of shrink or grow it however we want. So we can actually divide out all of the values in the ratio by square root of 2 in order to make the hypotenuse just x. That way, in our calculations, we know x will represent the hypotenuse length. So let's go ahead and let's do that. Let's just divide out by square root of 2. We end up with the leg then is represented by x over square root of 2. The other leg also x over square root of 2. And the hypotenuse just x. So now we have hypotenuse, as we're going through and working this out, will represent just x. So since the perimeter of the isosceles right triangle equals the sum of all of its sides, we can use the lengths in our ratio to find out what the perimeter is going to be in terms of our x values. So let's go ahead and take a look at the perimeter. Considering the perimeter using our lengths is just going to be the sum of all these sides. So x over square root of 2 plus x over square root of 2 plus x. Now we can simplify this a little bit, just scrolling down for a little bit more space. These are like terms, so we can combine them. There are 2x over square root of 2 plus x. Now usually we don't want to deal with square roots in the denominator, so we can actually rationalize this term right here. And to rationalize, we would multiply this term by the root we're trying to get rid of in the denominator. So square root of 2 over square root of 2. We still have this x floating about over here. So let's go ahead and continue simplifying this. I'm just going to scroll down to give us some more space. And simplifying our root, we have 2 square root of 2 times x all over 2, because square root of 2 times square root of 2 is just 2, plus x. And we can actually cancel these 2's. So we're left with square root of 2 times x plus x. Now we can actually just rearrange this to be a little bit nicer into x plus x square root of 2. Now this actually represents the perimeter. So pulling this back up just so that we can see our original question, I'm just going to take what we had down here and pull that all the way up. And we'll go over here. We had x plus x square root of 2 as our perimeter, and we're looking for whether this is going to equal, or how this will equal, 6 plus 6 square root of 2. Now even just comparing, the x's are in the right place, so if x is 6, they're actually equal to each other. We could algebraically solve this and factor out an x, then factor out a 6, cancel as we divide out and isolate x, and we would end up with x equal to 6. But if it's in the right form, we can just conclude that x is equal to 6. So remember, x represents the hypotenuse value. We kind of reasoned that out back here for us. So the correct answer choice is C. Another way we could solve this is we could plug in our answer choices. from the beginning. So using this ratio, we could, if we wanted to, plug in our answer choices to see which of the values would actually give us a perimeter of 6 plus 6 square root of 2. So either method will work. This method might be a little bit faster than actually plugging in our answer choices.